Hello, here we are with our last video for Chapter 1 in Section 6, Mathematical Treatment of Measurement Results. Here are your learning objectives. Basically, we're going to spend this video talking a bit about the process of dimensional analysis. Dimensional analysis is basically the converting of units. The process is also referred to as the factor label method, or the unit factor method. In some earlier videos in this chapter, I referenced some conversion factors. These are quantities that express how different units are equal. So for example, one I shared, 2.54 centimeters equals 1 inch. If I have conversion factors like this, then I'm able to convert between units. I know how centimeters and inches are equal, so using the factor label method, I can convert from either centimeters to inches or inches to centimeters. If I started with a value in centimeters, then I would set up my conversion factor, my equality, in this fashion. The key here is that you always want your units opposite so they cancel. So since I started a value out here in centimeters, that means centimeters in my conversion factor needs to be on the bottom. Centimeters is on top out here, on the bottom here, right? This is basically, we know this is basically over 1. So then this allows me to put my other unit in my equality here in my conversion factor on top. So I would effectively have canceled out centimeters and my answer would be left in inches. Look at a quick example. If I started with 34 inches and I wanted to know how many centimeters were in 34 inches, I would set up my conversion factor. Now in this case, I've started with inches, so then the unit inches, again, has to be opposite so it cancels, so centimeters would be on top. Now this equality doesn't change. Where the values go, top and bottom, could potentially change depending on what I start with out here, but the relationship between centimeters and inches does not change. So my conversion factor is 2.54 centimeters in every 1 inch. Now inches cancel. I would multiply across the top here and I would get an answer of 86 centimeters. Quickly, with regards to significant figures, these are the type of exact quantities and relationships that would not affect significant figures. I mentioned that in the last video. So when doing a dimensional analysis problem, I determine my significant figures from the measurement that I start the problem with. Excuse me, in this case, 34 inches, 2 sig figs. My answer needs to have 2 sig figs. In a dimensional analysis process, you are not limited to just using one conversion factor. You can use however many you need to go from where the problem is starting to whatever unit the problem is asking for. If I started this same problem, again with 34 inches, and this time the question was how many meters, I would start the process in very much the same way, because I don't know off the top of my head how meters and inches are equal. If I did, I could do that in one step in one conversion factor. But I do know pretty easily, because it's a equality I use quite a bit, a conversion factor I use quite a bit, that 2.54 centimeters equals 1 inch. Now, I've effectively converted from inches, but I haven't gotten to the unit that the question is asking for yet, which is meters. No problem. All I need to do is conversion factor. Now again, units opposite so they cancel. So since centimeters is on top in this conversion factor, I'll put centimeters down here. And I do know how centimeters and meters are equal. 1 meter is 100 centimeters. So now my centimeters cancel, my inches cancel. I'm left with just meters, multiply across the top, multiply across the bottom, and divide. and I would have a value of 0.86 meters. Here's a table with some common equalities that you may come across or may need to use to do some conversions. We'll have plenty of opportunities to practice using the dimensional analysis method in our in-class work and on some homework assignments. So we're going to move on from here. I will just say that this is a very important process that you will use quite a bit in chemistry, especially later in the course when we get to mole conversions and stoichiometry. The last part of this chapter covers temperature conversions. I've already discussed this a little bit in an earlier video when we talked about degrees Celsius and Kelvin and the relationship here. If you remember, there is exactly 100 increments between the freezing point and boiling point values in Celsius and Kelvin. The freezing point of Celsius is 0 degrees. This is again of water, if you recall. That's what we use for our reference temperature values. And for Kelvin, it's 273.15. The boiling point temperature of water is 100 degrees Celsius and 373.15. Again, just another reminder, it's degrees Celsius or degrees Fahrenheit, but just Kelvin. I said at that time that the conversion between Celsius and Kelvin is something we may have to do quite a bit of, and I showed you those relationships. If I wanted to determine the Kelvin temperature, it would be the Celsius temperature plus 273.15. If I needed to determine the Celsius temperature from the Kelvin temperature, it would be minus 273.15. We also, at times, may need to convert from Fahrenheit to Celsius. You saw earlier in a prior video for this chapter some conversion between English units and SI base units. And so that may be something that you would come across again. And so here is the conversion for from degrees Celsius to degrees Fahrenheit or vice versa. If you have a temperature in Fahrenheit and need to get it into Kelvin, it would just be a two-step process where you would first use this formula, then you have it in degrees Celsius. You can then go from degrees Celsius to Kelvin by adding 273.15. Okay, that wraps up section 6 from chapter 1, and therefore also wraps up chapter 1. As I mentioned here in this video, we will have plenty of practice on dimensional analysis. This was just a quick introduction, and now we'll spend some good time practicing it to make sure everybody's comfortable with this concept.